Understanding the Linux file system hierarchy is a fundamental skill for anyone working in cybersecurity or system administration. You have already practiced navigating the file system using commands like pwd, ls, cd, and tree. Now it is time to understand what you are actually navigating, the logical structure that organizes every file, directory, and resource on a Linux system. Linux does not use drive letters like Windows, C, D, etc. Instead, everything starts from a single root point, represented by a // This is called the root of the file system. Every file, directory, device, and process on the system is accessible from this single starting point. Whether you are looking at a hard drive, a USB key, a network share, or a virtual device, everything appears under this unified tree structure. This organization follows an international standard called the File System Hierarchy Standard, which defines the purpose and content of the main directories found on Linux systems. Understanding this standard is not just theoretical. In a cybersecurity context, knowing where files are stored, which directories are writable, which contain sensitive data, and which are used by system processes is essential for auditing, penetration testing, and hardening a system. The root directory. The root directory is the absolute top of the hierarchy. Every path on the system starts here. When you ran pwd earlier and saw something like /home/alice, that path started from /. The root directory itself contains all other directories. Only the root user, the system administrator, has full write access to this directory and its immediate children. This is an important security boundary. The /bin directory. /bin stands for binaries. It contains essential executable programs that must be available for all users, even during system recovery or before other file systems are mounted. Classic examples include ls, cp, mv, rm, cat, echo, and bash. These commands are available system-wide and do not require special privileges to run. In a security audit, reviewing what is present in /bin can reveal unexpected or malicious executables placed there by an attacker. The /spin directory. /spin stands for system binaries. It contains essential administrative commands that are typically reserved for the root user. Examples include iptables, the firewall configuration tool, fdisk, disk partitioning, ifconfig, network interface configuration, and reboot. Regular users can often see these files but cannot execute them without elevated privileges. In a penetration testing context, gaining access to /spin commands is often a sign of successful privilege escalation. The /etc directory. /etc is one of the most important directories from a security perspective. It contains system-wide configuration files. These are plain text files that control the behavior of the operating system and installed services. Key files to know include /etc/password contains the list of all user accounts on the system, including usernames, user identifiers, group identifiers, home directories, and default shells. It does not contain actual passwords in modern systems but is still sensitive. /etc/shadow contains the encrypted password hashes for each user. Only the root user can read this file by default. Accessing /etc/shadow is a major goal during a privilege escalation attack. /etc/hosts maps host names to IP addresses locally, before any network lookup. /etc/sudoers defines which users can run commands with elevated privileges using sudo. Misconfiguration of this file is a common vulnerability. /etc/ssh/sshd_config configures the secure shell daemon, which controls remote access to the system. During a security audit, /etc is one of the first directories to examine. Misconfigured files here can expose the entire system. The /home directory. /home contains the personal directories of regular users. For a user named Alice, her home directory would typically be /home/Alice. This directory stores personal files, configuration files specific to that user, often hidden files starting with a dot, like bashrec or ssh, and downloaded content. From a forensics or penetration testing perspective, /home directories often contain private keys, credentials, scripts, and browser history that can be highly valuable. The /root directory. /root is the home directory of the root user, the system administrator. It is separate from /home and is only accessible by the root user. Finding sensitive files, scripts, or credentials in /root is common during post-exploitation phases of a penetration test. The /tmp directory. /tmp is a temporary directory used by applications and users to store short-lived files. It is world-writable, meaning any user can create files here. It is often cleared on reboot. In cybersecurity, /TMP is frequently used by attackers to drop malicious scripts or payloads because it is writable without special privileges. Monitoring writes to /TMP is a standard intrusion detection practice. The /var directory. /var stands for variable. It contains files whose content changes frequently during system operation. Important subdirectories include /var/log, contains system and application log files such as /var/log/auth.log, authentication events, /var/log/syslog, general system messages, and /var/log/apache2/access.log, web server access. Logs are critical for incident response and forensic investigation. /var/www, typically the root directory for web server content. Files served by a web server like Apache or Nginx are often stored here. /var/mail, stores incoming mail for users. /var/spool, holds queued data for processes such as printers or scheduled tasks. In a security investigation, /var/log is always one of the first places to check for traces of intrusion or suspicious activity. The /user directory. /user stands for Unix System Resources, not user, as is often mistakenly assumed. It contains the majority of user utilities and applications. Key subdirectories include /user/bin, contains non-essential binaries for regular users, such as Python 3, Git, curl, or Weejay. /user/spin, contains non-essential administrative binaries. /user/local, used for software installed manually by the system administrator, outside of the package manager. This is often where custom tools are installed. /user/share, contains architecture-independent data files shared by applications, such as documentation and default configuration templates. The /opt directory. /opt is used for optional or third-party software packages that are self-contained. Security tools like Metasploit or custom enterprise applications are often installed in /opt. Knowing what is installed here can reveal the security posture and tools available on a target system. The /proc directory. /proc is a virtual directory, meaning it does not contain real files stored on disk. Instead, it is dynamically generated by the kernel and provides real-time information about running processes and system resources. For example, /proc/1 contains information about the process with identifier 1, typically the init or systemd process. /proc/cpinfo contains details about the processor. /proc/net/tcp lists active TCP connections. This directory is invaluable for live system analysis and is heavily used in both system administration and penetration testing for gathering information without running intrusive commands. The /sys directory. /sys is another virtual directory, similar to /proc, but focused on exposing kernel data structures and hardware device information. It is used for interacting with device drivers and kernel modules. Advanced security tools sometimes read from /sys to detect hardware-level configurations. The /dev directory. /dev contains device files. In Linux, hardware components are represented as files. For example, /dev/sda refers to the first hard drive. /dev/null is a special file that discards everything written to it and is often used in scripting to suppress output. /dev/random and /dev/urandom provide random data, which is used in cryptographic operations. Understanding device files is important in advanced scenarios such as forensic disk imaging or capturing network traffic directly. The /lib and /lib64 directories. /lib and /lib64 contain shared library files used by programs in /bin and /spin. Libraries are reusable blocks of code. For example, the C standard library is located here. An attacker who can replace a shared library with a malicious version can compromise every program that uses it, a technique known as library hijacking. The /boot directory. /boot contains the files needed to start the operating system, including the kernel itself and the bootloader configuration, such as grub. Unauthorized modification of files in /boot can prevent the system from starting or introduce a persistent backdoor at a very low level. The /media and /mnt directories. /media is the standard mount point for removable media such as USB drives or optical discs. When you plug in a USB key, it often appears under /media/username/device name. /mnt is a generic mount point used by system administrators to temporarily mount file systems, such as network shares or additional disk partitions. Security implications of the file system hierarchy. Knowing this structure allows a cybersecurity professional to think like both a defender and an attacker. When conducting a penetration test or a security audit, the file system hierarchy guides your investigation. You know to look in/etc for configuration weaknesses, in/var/log for traces of activity, in/home and/root for sensitive user data, in/tmp for dropped payloads, and in/proc for live system information. For system hardening, you apply specific protections to sensitive directories, mounting /tmp with the no-exec option, preventing execution of files from /tmp, restricting read access to /etc/shadow, monitoring changes to /bin and /spin, and auditing rights to /var/log. The file system hierarchy is not just an organizational convention. It is a map of the system that tells you where to look, what to protect, and what changes could indicate a security incident. Mastering it is a prerequisite for every advanced Linux security task you will encounter in this course.